So good afternoon to all. So this is Kumar from SNS College of Technology and Department of Computer Science and Engineering. So now I'm going to tell about threads in operating system and multi-threading models. So what is multi-threading? So most modern applications are multi-threaded. So thread run within applications, so not with the softwares, and multiple tasks within the applications can be implemented by separate threads like updated display and fetch data and spell checking and answer a network request. So process creation is a heavy weight while thread creation is lightweight. So it can be simplify code and increase efficiency with the kernels, or generally multi-threaded programming are used. So multi-thread server architecture, we have a client and thread, client and server, and auxiliary thread. So client request one from the one processor to server, and server resuming listening to additional client request of the new one. So create a new thread to service the request. So this is called the multi-thread server architecture. So benefits, so responsiveness and resource sharing and economy and scalability. So responsiveness may allow a continued execution if a part of process is blocked, and especially important for user interfaces. And resource sharing, so thread shares resource of process, so easier than the shared memory or message passing. So and economy, cheaper than the process creation, and thread switching lower overhead than the context switching. And scalability, so and process can take advantage of multi-process architecture. Multi-core programming, so multi-core or multi-process systems putting pressures on programmers, and the challenges included like dividing activities and balance and data splitting and data dependency and testing and debugging. And parallelism implies a system can perform more than one task simultaneously, and also is using a concurrencies, supports more than one task making progress, and a single process or a core or scheduler providing concurrencies. And multi-core multiple systems putting a process and the concurrency systems. So and the concurrency is a parallelism, the concurrency execution on single core system, and a parallelism on a multi-core system. We have a single core with a single time. So in a multi-core we have do different core 1 core 2 with the same timing. So the same timing we have different process, multiple process are completed. Single and multi-threaded process architecture, so single threaded process we have a same thinking register and stacks, and the multi-threaded process we have a register and we have more than one register and more than stacks for storing the data of the programs. So user threads and kernel threads. And user threads means management done by user level threads library. So the three primary threads are library on POC6 threads and Windows thread and Java threads. In a kernel threads is supported by the kernel. Example, virtually all general purpose operating systems including Windows and Solaris and Linux and True 64 Unix and Mac OS X. Likewise, multi-threading models. So we have three different multi-threading models here operating systems. So one is a many to one, and one to one, and many to many. So first one, many to one. So in this many to one means the many user level threads map to single kernel threads. So one thread blocking causes all to block. So multiple threads may not run in a parallel on multi-core systems because only one may be kernel at a time. So few systems currently use this model. Example, Solaris green threads and GNU portable threads. So in the right side we have a user thread and a kernel thread on many to many architecture. So next one to one. So each user level threads maps to kernel threads. So and creating a user level threads creates a kernel thread. So it is a more concurrency than a many to one thread, and that is also number of threads per process sometimes restricted due to overhead. For example, Windows and Linux and Solaris 9 and later. So in the right side we have a user thread and kernel thread one to one architecture. So next one, many to many model. So allows it allows many user level threads to be mapped to many kernel threads. So it allows the operating system to create a sufficient number of kernel threads, and the Solaris prior to version 9. And also the Windows with the thread fiber package, for example user thread and kernel thread. Two level models, so similar to mm model. So expect that it allows a user thread to be bound to kernel threads, example RX and HPUX and 36B 64 Unix and Solaris 8 and earlier. So in the right side we have a different user thread and kernel thread with common prototype models. Thread libraries, so thread library provides a programmer with the API application program interface for creating and managing threads. So two primary way of implementing will using these thread libraries. One is a library entirely in user phase, and a kernel level library supported by the operating system. So p threads, so the p threads may be provided either as a user level or a kernel level. So a POSIX standards IEEE 10003.1c and API for thread creation and synchronizations. So we have two different specification, not implementation in the p threads. So API specifies behavior of the threads, and implementation is up to development of the library. So common in Unix operating system Solaris and Linux and Mac OS. So P3 compared with the threads, P3 is a more advanced threads of in language. And then thread pools, so it create a number of threads in a pool where they are way to work. So advantage of thread pools is usually slightly possible to service a request with an existing thread, create a new thread, so allows the number of threads with applications, and separating the tasks to be performed from the mechanics of creating tasks allows. So Windows API support thread pools with different applications. So thank you.